y over x, because it's sine over cosine for tangent. So this becomes 2 times 1, which is just 2. So the limit as theta approaches pi is that. Can we go with that? Okay, so now we're going to talk about what if it doesn't come out nice and neat like this. We know a lot of things do not come out nice and neat. So we're going to look at this expression. And we're going to plug in 0. And we can use that unit circle that we drew above. 0 is the same as 2 pi. What's the cosine of 0? Right here. Yep. It is 1. So 1 minus 1. And the sine of 0? 0. So we have trouble.
Like that 0 squared doesn't do anything?
So, since there's trouble, we got to figure out a way to do this. Well, it's not like with the algebraic ones where we can just factor, or we have to figure out other ways. So some of those other ways involve, and I know y'all are going to love this, trig identities. So, like if I had sine squared plus cosine squared.
Oh, yeah, I think I still have that thing.
What's sine squared plus cosine squared? It's 1. Now we can write that a whole bunch of different ways. Sine squared is the same thing as 1 minus cosine squared.
Wait, did you ever give us back those cards you used? Because I also might have.
You wouldn't be able to use the cards on these tests. So.
What about the quiz?
Anything in your notes, and you're about to have it in your notes. So. Tangent of theta, we said just a minute ago, was sine over cosine. Cotangent, what would that be?
2 sine over sine.
What over sine?
1 over tangent.
1 over tangent, true. Put it in terms of sine and cosine.
Cosine over sine.
There you go, yeah. And that may have been what you said earlier, I just couldn't hear it. The secant is 1 over the cosine. Cosecant is 1 over the sine. This one you probably really don't remember because we don't use this one as often. Sine of 2 theta is 2 times the sine times the cosine. So those are just a few that we use. Probably the most common ones that we will use. Oh, okay. Okay, so we are still going to do the limit as theta approaches 0 of 1 minus cosine of theta over sine squared of theta. But we know we have to do it in a different way because it gave us an issue. So, we can rewrite sine squared of theta pretty easily using this stuff. Oh, it completely locked up. So what is, there we go. What can I plug in instead of sine squared of theta?
1 minus cosine of theta squared.
Yes, right here. Sine squared of theta is equal to that. So, limit as theta approaches 0. 1 minus cosine of theta is the same as 1 minus cosine squared of theta. Can I just cancel out those 1s and cosine? No.
No.
Because addition and subtraction. Cannot. What can I do?
Plug it in again.
I can plug it in again. It's still going to give me 0 over 0 though.
Dig.
Would they both go to 1? They both be 1.
It'd be 1 minus 1.
Yeah.
Almost.
Pretend it isn't cosine squared. Pretend it's x. But if it was 1 minus x squared, what could we do?
Factor.
We could factor.
Take out negative.
So by factoring, think of it, it's a difference of 2 squares. 1 minus x squared, that'd be 1 plus x and 1 minus x. So here it'd be 1 plus cosine theta and 1 minus cosine theta. Now, what happens?
Cancel.
Yeah, the 1 minus cosine thetas cancel. So I have 1 over 1 plus cosine of theta. If I plug in 0, 1 plus cosine of 0, which is 2, would be indeed 1/2.
Yeah, we're doing this again.
Aren't you excited?
Yeah, this is probably the hardest test we took.
Oh,
Yeah, this test was pretty good.
Yeah, but like we had like that little note card that she said that we could like write whatever we wanted on it. At least it was for that test. I think we could do it on
well, this one, honestly, there won't be that many that she used. We're going to be using the same ones over and over and over again. So, okay, so we're going to do the same thing on these. We have the limit as theta approaches 3 pi over 2 of 3 tangent theta cosine of theta. So we just plug it in like we see it. 3, and I'm not going to have room there.
I bet it equals 0.
Oh wow, I didn't know that.
So 3 times the tangent of 3 pi over 2, and then times the cosine of 3 pi over 2. 3 pi over 2, use a unit circle, it's this bottom one.
Yeah, so it would be like
0, negative 1.
Yeah, but like for tangent you have to is it y or x?
Yes.
Yeah, you're already stuck.
Already issues.
I was like,
Yeah.
I don't think we have to do anything.
Yeah, because right here, uh-oh, it's undefined. So, just the sound of 2020.
That is true.
It is true. So it reminds me of teaching my very first calculus class, first time ever. And occasionally we would get so frustrated because we were all learning it together. Not that I hadn't had calculus before, but I had never taught it before. And every now and then we would go outside and just scream. And it was wonderful.
That's how brain breaks happen.
That is kind of how it happened, yes. And now we can't do them. All right. Anyways.
Oh, Mr. Carter said you couldn't do it?
Well, I just know we can't because we're moving to a different location, which possibly makes us closer to people that we wouldn't be. They need to know, like, exactly where you're sitting. And, yeah, like, I have to keep a seating chart and just in case. Okay. So, how can I rewrite something to make something go away?
Turn tangent into
Sine over cosine.
Yes.
Would
Excellent.
that cancel out?
Yes. So tangent, make it sine over cosine. And it's all multiplication. So you have a cosine on top and a cosine on bottom.
Boom.
Boom, they cancel.
Was it that easy? Or?
It really was.
Okay. Is it true?
Yeah. It is. I'm not messing with you.
So it'd be -3.
So it'd be 3 times the sine of 3 pi over 2. And yes, 3 pi over 2, the sine of that is a -1.
Let's go.
So you are right.
That wasn't too bad.
See?
I know, but I thought it was trickery. So.
Trickery.
Yeah.
It was not trickery.
You sure?
I'm sure. Okay, let's look at 2.
What's secant?
Secant.
1 over cosine.
Yes, it is.
It's the weird like opposite thing.
Yeah.
Cotangent.
Secant is the reciprocal of cosine.
See, I couldn't think of the word for it, but I knew it was the opposite.
Now, I'm just going to plug in pi over 2, just so we can show that it is indeed an indeterminate form or something. Oh, well, this doesn't help if it's in front of the